ಎಲ್ಲರಿಗೂ ಸ್ವಾಗತ. ನಮ್ಮ ಹಿರಿಯ ಅಕಾಡೆಮಿಯ ಎಸ್ಟೀಮ್ಡ್ ಮೆಂಬರ್ ವಿಶ್ರಾಂತ ಕುಲಪತಿಗಳು ಗುಲ್ಬರ್ಗಾ ವಿಶ್ವವಿದ್ಯಾಲಯ ಹಾಗೂ BLDA ವಿಶ್ವವಿದ್ಯಾಲಯ ಪ್ರೊಫೆಸರ್ BG ಮುಲಿಮನಿ ಸರ್ ಇದ್ದಾರೆ. ಅವರಿಗೆ ಈ ಒಂದು ವೆಬಿನಾರ್ಗೆ ಸ್ವಾಗತ. ಹಾಗೆ ನಮ್ಮ ಅಕಾಡೆಮಿಯ ವಿಶೇಷ ಆಹ್ವಾನಿತ ಸದಸ್ಯರು, ಹಿಂದಿನ ಅಕಾಡೆಮಿ ಸದಸ್ಯರು ಆದ ಡಾಕ್ಟರ್ ನಾಗೇಶ್ ಹೆಗ್ಡೆ ಸರ್ ಇದ್ದಾರೆ. ಅವ್ರಿಗೂ ಸ್ವಾಗತ. ಇಂದಿನ ಉಪನ್ಯಾಸವನ್ನು ನೀಡಲಿರುವ ಡಾಕ್ಟರ್ BR ಗುರುಪ್ರಸಾದ್, ಫಾರ್ಮರ್ ಅಸೋಸಿಯೇಟ್ ಡೈರೆಕ್ಟರ್ P&PR ಡಿವಿಷನ್ ISRO, ಅವರು ನಮ್ಮ ಜೊತೆ ಇದ್ದಾರೆ. ಅವರಿಗೆ ನಮ್ಮೆಲ್ಲರ ಪರವಾಗಿ ಹಾರ್ದಿಕ ಸ್ವಾಗತ. Before actually starting the talk, let me give a brief introduction of achievements of Dr. Guruprasad sir. Dr. Guruprasad has done his BSc with PCM combination. Sir, physics, chemistry and mathematics. Then he has done his master's in communication and journalism. Later pursued doctorate and obtained PhD from Mysore University. He also has obtained proficiency certificate in the subject Principles of Flights. Dr. Guruprasad had 37 years of illustrious career in the most reputed organization, that's ISRO. He has rich experience in satellite mission planning, analysis and operation, and he has worked for over 25 Indian satellite missions at ISRO Satellite Center, which is now called UR Rao Satellite Center. Dr. Guruprasad has also worked at German Space Agency and also NASA. He was invited to Japan in 2008 by Japanese Aerospace Exploration Agency as a member of the panel on space education for young, and he was also invited to France in 2010. Dr. Guruprasad has delivered more than 500 talks on various science topics, both physically as well as through All India Radio and television. He has conducted many water racket making workshops and launch competitions. And one more very interesting and very noteworthy thing is he has conducted more than 150 science quiz programs across the state. He has visited many countries including the US, Australia, and many European and Middle Eastern countries. Dr. Guruprasad will be delivering a talk on James Webb Space Telescope, a giant leap for astronomy. As all the participants know, it was launched on 25th December. Sir will be talking about its objective and mission. Now, with this brief introduction, I request Dr. Guruprasad to take over and deliver his talk. Sir, over to you.
Yeah. Hope I'm audible. Okay.
Yes, sir.
Okay. Now, first, I would like to thank KSTA, Professor Ayyappan, and its chief, Professor Ayyappan, and Dr. Ramesh, okay, for having invited me here. Dr. Ramesh is the one who is in touch with me continuously, and I especially thank him and all his assistants, also people who work with him for web-related things, Umesh and Anthony and others. Now, the thing is, thanks Dr. Ramesh once again for the long introduction. Anyway, I'm very proud to say in the beginning itself, I was proud to be part of Indian Space Research Organization for 37 years. Okay, now I'm no longer part of it because I superannuated in May 2020. But now I am an academic. But at the same time, really it is a wonderful time for me because I learned everything. Okay, ISRO was the great university for me. In addition to fact that it provided me salary, it provided me all the facilities, good posts and all those things. But at the same time, it was very instrumental in making my knowledge horizon very broader. I thank them. I always cherish my memory of working there. Now, when I was asked to talk about a subject to PU students or even others at a little bit higher level, and even to a certain extent academicians, I chose the subject James Webb Space Telescope, a giant leap for astronomy. Okay, why? This is the most widely debated topic today as far as science is concerned, as far as astronomy is concerned. Really, James Webb Space Telescope is claimed to be a giant leap, no doubt about it. Neil Armstrong said, that's one small step for a man, one giant leap for mankind. Is it really a giant leap? No doubt about it. From technological point of view, from the point of view of its presence, where it is, its location, its capabilities, okay, in its complexity, from all points of view, it's a giant leap, technologically and scientifically both. Okay, now let us take a look at what is so special about this James Webb Space Telescope. Today, thousands of satellites are circling the Earth in different orbits. Okay, circling the Earth, and nearly 9,000 satellites are there. Out of that, one third of them they are working satellites. All others are junk. Okay, but anyway, they are circling there. Okay, whether you like it or not, and many of the satellites, or most of the satellites, they are either they look like boxes. Okay, look there, in fact, boxes like this, or even they may look like cylinders, in fact. Okay, they are providing a lot of help. Okay, space is influencing our daily lives more than ever today, whether it is for telecommunications, television broadcasting, high-speed internet data, weather forecasting, or survey and management of natural resources, disaster management, navigation, position and time, and all those things. You will not be able to imagine so many areas in which satellites contribute a lot. They are a part and parcel. They are an integral part of the global economic infrastructure, and especially so in India. But look at that. Satellites are circling the Earth like this. See, this is one small satellite which is going around the Earth. But just I want to show you how a satellite, when it goes around the Earth, how it looks. This is an animation of a small satellite going around the Earth. Okay, so satellites are doing wonders as far as human life is concerned. But, excuse me, compared to those satellites, there is yet another satellite, or even you call it as a spacecraft. Okay, spacecraft and satellites, to a certain extent, they differ. Okay, anyway, let us call it as a satellite. There's a huge satellite today, artificial satellite, which doesn't look like as though it is a box or even a cylinder, and it doesn't contribute to communication, weather forecasting, disaster management, or navigation. Look at that. It looks like a giant hexagonal mirror. Okay, hexagonal mirror here on a platform which is so huge. This platform is as big as a tennis court, in fact, here, this platform. And on top of that, there is a mirror here, golden colored mirror. And this satellite is moving away from the Earth, and almost it has reached a distance of, let us say, about 1,000,000 miles or 1.5 million kilometers from the surface of the Earth, in a direction opposite to that of the sun. If there is a, let us say, there is a straight line between the sun, the straight line connecting the sun and the Earth, and produce it in a direction opposite to that of the sun, on that line, at a distance of 1.5 million kilometers from the Earth, this has almost reached. Okay, this is the thing. So this is the James Webb Space Telescope, and this was launched on Christmas Day of 2021. See, normally Christmas Day means in Europe, they take off, and even when I was there, I had seen them, how much of emotional attachment is there for them. But on that day, Christmas Day, when this James Webb Space Telescope was about to be launched, they were not bothered about holiday. They were not even bothered about their breakfast, actually. Because somebody commented, what did those scientists eat for breakfast? Their fingernails, it seems. They were so excited, and they were so agitated because the launch was very important. This was the Ariane rocket, which was standing in French Guiana. Okay, so the thing is in northern tip of South America, and this 17-story rocket, it lifted off majestically. And before that, I would like to say that this is the region in which that James Webb Space Telescope was sitting there comfortably, sitting with its arms and legs totally folded. Okay, that's the way it was. And I'll show you a bigger thing. See, its arms and legs are just folded. Here it is only 5 meters. Here, within that it is sitting. And look at that. James Webb Space Telescope is being cocooned inside a heat shield of this Ariane rocket. Okay, so that's the way. Then there was a majestic liftoff at 5:50 p.m. on the Christmas Day, 2021, Indian Standard Time. And within about 27 minutes, the James Webb Space Telescope had reached space, and it had achieved a good speed, okay, thanks to Ariane 5 rocket. Look at that, this was the liftoff. And once it cleared the Earth's atmosphere, there was no need to have this heat shield of the rocket. It was a liability, it was thrown out, and James Webb was exposed. It doesn't matter because there are no aerodynamic forces there, okay? Then the last stage of Ariane rocket, okay, Ariane 5 rocket, achieved a speed of around 36,000 kilometers per hour. Our average speed in Indian roads is about 30 kilometers per hour, average speed. This is more than 1,000 times that speed. We can't even imagine, but such speeds are essential if we want to go much beyond the Earth. Okay, anyway, that provided the kick and the speed essential for James Webb Telescope. And look at that, this is the real picture of the James Webb Telescope. This is not animation. See how it is glittering as it separated from the last stage of the Ariane rocket. This was the last picture of James Webb Space Telescope as it sped away from the Earth. Okay, now look at that, how the James Webb Space Telescope was built. I'll just show you a small video. Okay, look at
has been the most
say this is the way it is. Okay, earlier there was another satellite called Hubble. I will come to that. This is the James Webb Space Telescope, what it will see. So I'll tell you about these things, but I want you people to see as to what it will do. I'll give you the details, but anyway, I want to show you as to how critically it was built and how difficult it was for the scientists in America and Europe and Canada to build this satellite. Look at that, okay? And see, it consists of 18 hexagonal mirrors. Look at that golden colored mirror. I'll come to those things a little later. Look at that. This is the thermal shield, which is as big as a tennis court. And this is a chamber where the conditions of space are recreated and it was tested there. And this is the way the folded portion of a folded state of James Webb Space Telescope looks. And earlier launch date was October 2018. Don't worry about it. See, this is the way when it was folded, it looked like that. First thing, as soon as it separated from the rocket, was the solar panel, then the communications antenna, then the two pallets. And look at that. This telescope has gone up from the rest of the satellite. And look at that. There are 5 layers of insulation material, that is the heat shield material. And mirror itself was folded and it has opened up. Now this is the way James Webb Space Telescope looks, because it has almost reached its destination, which is about, let us say, 1.5 million kilometers from the Earth. I will tell you what it is. So let us say this is sufficient, this video. And what I wanted to tell you was this. And now let us go to the next slide. And sorry. Okay, this is the way James Webb Space Telescope looks now. If you have the, let us say, ability to go near James Webb Telescope like a proverbial Hanuman, then you will see it like this. This is a mirror which is 6.2 meters diameter, okay, nearly 20 to 22 feet. And this is a thermal shield which is as big as a tennis court. Actually, there are 5 of them. So this is the way it looks. Now, whenever I say James Webb Space Telescope, I said it is the giant leap for astronomy. Why do people are talking about like this? What is so special about it? Aren't there other satellites already which were launched earlier? Haven't they done good work? No doubt about it. What is so special about James Webb Space Telescope? First of all, who is this James Webb? Okay, why his name has been kept? Okay, this is Dr. James Webb, who was the director of NASA, okay, National Aeronautics and Space Administration of the United States, in the 60s when they had lunar program. They had to beat the Soviets and reach the moon. He was instrumental, and he supported a lot as far as space telescopes were concerned. So in honor of him, they have named the space telescope as the new space telescope as the James Webb Space Telescope. Now, in order to understand the significance of James Webb Space Telescope, the way it works, how it functions, and what it is supposed to do, how significant what it does. In order to understand these things, first of all, you have to start with telescopes. For thousands of years, humans have observed the Earth, humans have observed the night sky. Okay, curiously. First, they were scared about the events, especially the eclipses, the setting of the sun, okay, comets and all those things. But slowly, they started observing certain patterns, okay. But for a long time, thousands of years, they relied on their two eyes. Then, in 1609 AD, there was a great scientist of Renaissance by name Galileo Galilei, who used a newly discovered gadget called telescope, okay, to observe the heavens. Look at that. This is the telescope. What is so special about a telescope? Compared to the light collecting ability of your eye, telescope has an aperture which is much bigger. It collects more light, and that is why it shows details, and it makes it appear as though distant heavenly bodies are nearby. So the more the aperture, the more light collecting ability. And this is Galileo Galilei, and he looked at the heavens through his telescope. He looked at the moon and saw, let us say, he saw the mountains on the moon, craters on the moon, lowland areas on the moon, and he foolishly turned it towards the sun and became blind in his old age. Don't look at the sun using a telescope. Nobody will do even through naked eyes, because what is there? Sun is there every day. Nobody sees it. Okay. But anyway, it is very dangerous to look at the sun through a telescope directly. But anyway, he saw that. He saw the surface of the sun. He cited what is known as sunspots. It was good for science, bad for Galileo. Okay, that's the way it was. Then, Galileo's telescope consisted of lenses. One lens on objective on this side, eyepiece on the other. But as you build larger and larger telescopes, it is not easy to build them because they have lenses which is not easy to be made, not easy to make. Lots and lots of difficulties will come. I don't dwell upon that. But anyway, this genius by name Sir Isaac Newton developed another type of telescope called refracting telescope. That is, instead of having lenses, he used the mirrors. Okay. So on one surface of mirror can be polished, and you can focus the light to a particular point, and it is relatively easy to build a reflecting telescope consisting of mirrors rather than a refracting telescope consisting of lenses. Okay, big telescopes were built like this over a period of time after Galileo's time and Newton's time, reflecting telescopes. Then in the 19th century, there was this German scientist by name Joseph Fraunhofer. He split the light coming from a telescope, let us say, using a slit, okay, and the light which was spread, he analyzed it and he found lines which indicated the elements present in that the spectrum of the heavenly body. So this was a very, very major development as far as astronomy was concerned. Through telescopes, you can see things, but if you want to analyze what are the atmospheres of different heavenly bodies or what their composition is, you have to study their spectrum. That is what Fraunhofer did. And now, telescopes on the surface of the earth, mostly they rely on visible light. That's what I said. Thousands of years, human beings have relied on visible light. So visible light is only one kind of electromagnetic radiation. Okay, James Clerk Maxwell, a great physicist in the 19th century, he predicted the existence of electromagnetic waves, in the sense it consists of electric and magnetic fields and all those things. He said light is one kind of electromagnetic radiation. So similarly, there are other kinds of electromagnetic radiation. On the one side, when you have more wavelength, you have infrared rays, you have microwaves, you have radio waves. On the other side, when wavelength is less compared to visible light, you have ultraviolet, you have X-rays, you have gamma rays. But alas, the problem is from the surface of the earth, you can study only visible light, and for all practical purposes, radio waves. That's all. Ultraviolet and infrared, for the most part, they don't reach the surface of the earth. And X-rays, gamma rays, and they are totally filtered out by the atmosphere. Of course, it is good for our life. Okay. So the thing is, it is very good for us. Otherwise, we get killed if gamma rays, X-rays, and all those things were to reach. So whatever is good for our survival on the surface of the earth is bad for astronomy, because if you want to understand universe in its entirety, if you want to understand universe holistically, then you have to study different kinds of electromagnetic radiation. It is like, opening only one window from a room, and what you see is a limited portion of the outside world. As you open many windows, you see the world in its entirety, outside world in it. Similar to that. But anyway, other than visible light and radio waves, for all practical purposes, other kinds of electromagnetic radiation doesn't reach the surface of the earth. So this is the Earth's atmosphere. You can see the hazy layer there. Okay, it's good for us, bad for astronomy. Okay, and these are the telescopes. You can see hexagonal mirrors there. It is a telescope is in Hawaii called Keck telescope, and this is a radio telescope. Okay, so this is a radio telescope, and for a long time humans craved for sending something to space to study every kinds of electromagnetic radiation from distant heavenly bodies to better understand the universe. But having aspiration is one thing, aspiring something is different, having technology is another thing. But anyway, by 1957, rockets which were very large enough and could be, which had the ability to place satellites into orbit were developed. And after that, so many satellites have been launched. Thousands of satellites have been launched by humans. Some of them are scientific satellites. Look at that. There is one scientific satellite. Forget about communications, meteorological, that is weather forecasting satellites, survey and management of natural resources, that is Earth observation satellites and navigation satellites. They're all related to human life. But this is about the quest of humans to understand the universe. Look at that. This is a scientific satellite called Hubble Space Telescope. It is circling the Earth at roughly 600 kilometers height. Okay, it has done wonders. Similarly, this was infrared space observatory. Infrared space observatory. This similar to that, there is one Lyman Spitzer observatory. Hubble Space Telescope, mostly visible and very little infrared and ultraviolet capability it had. This is purely infrared. This is Chandra X-ray Observatory, named after Dr. Subramanian Chandrasekhar, Indian-born American scientist and Nobel laureate. Look at NASA, they have named after him. This is X-rays. This can study X-rays. And don't forget, my dear friends, everything is not from the outside world. Today, you have a finest observatory called AstroSat, which was launched by your own rocket called PSLV in September 2015. I was there for the launch of that. This satellite has got 4 eyes. It can see visible light, it can see 2 types of ultraviolet light, it can see different types of X-rays, and to a certain extent, it can see gamma rays also. There is much to be done, okay, and it is working well. That is what is important. India is also not, you cannot just dismiss it. Anyway, I'll come back to Hubble Space Telescope once again. Hubble initiated a revolution in astronomy, the first revolution in astronomy, because it had the ability to see galaxies which are very far away. And more than distant galaxies, look at that. Stars are born in stellar nurseries called nebulae, okay? Gas and dust. They are giant clouds, are not clouds in the atmosphere, not like that. They are giant clouds of gas and dust. This is called pillars of creation, okay? This is one picture sent by Hubble about nebulae, okay? How stars are formed. They could able to gauge such things. And once upon a time, a few years back, Hubble was made to focus its vision on a patch of sky, small patch of sky, which was very dark. When they focused it for a long time and saw, scientists, the astronomers were really thrilled because they saw galaxies which were as far away as 13 billion light years. 13 billion light years, almost at the beginning of the universe. Not at the beginning of the universe, almost. But they were fuzzy galaxies. Okay, Hubble showed it, but not much details. And James Webb Space Telescope is going to revolutionize these things. The study of the first galaxies, the kicking up of first light when the universe was lit up for the first time, that light is what James Webb Space Telescope is supposed to see. James Webb Space Telescope, that's what I said. These are the galaxies shown by Hubble. It's going to see how these galaxies are formed. Similarly, how stars are formed. What about the atmospheres of planets which are circling the other suns? And coming to, don't forget about, forget about distant bodies, our own solar system. There are icy bodies at the edge of our solar system called Kuiper Belt. There, many bodies which are like Pluto, they have been discovered. And even Hubble Space Telescope could not see them in detail, but James Webb will see that. Now let us come to the building of James Webb Space Telescope. Even before Hubble was launched, scientists were sure that if we want to see the early universe, that is back in time towards the beginning of the universe itself, as to how first galaxies and stars were formed, you cannot rely on visible light or any other kinds of electromagnetic radiation. Why? That is because whatever light that started as ultraviolet light or visible light at that time, that is when the universe was formed when the first galaxies were formed 13 billion years back, that light, due to the expansion of the universe, like Doppler shift, it has red shifted towards the red end of the spectrum, beyond red, infrared. That is why if you want to see the formation of first galaxies and stars, you have to have a telescope which studies infrared light, not visible light. But the problem with infrared light is, the thing is, all bodies above absolute zero, they emit infrared radiation. If you have James Webb Telescope near the Earth, much of the time it will be in Earth shadow, and it is affected by the heat from the Earth itself, heat from the sun itself. Then where will you take it? That is why they decided, let us take it to a distant spot where it is cold enough. At the same time, it is shielded by and large from the radiation from the Earth and the sun and the moon. But it has to be stable. Okay? You cannot have place it in a point where it will not be stable at all. It will be oscillating and all those things. Means it would be very difficult to communicate with the James Webb Space Telescope. That's why they chose what is known as L2 Lagrangian point. Okay, it's about 1 million miles or 1.5 to 1.6 million kilometers from the surface of the Earth. So how did they build the telescope? This is, Hubble had a aperture width of around 2 meters. This is more than 3 times that. But that's okay. You can build all these things very well with great difficulty. But how are you going to launch it? There is no rocket which can accommodate this big telescope and launch it in that position. That is why ingeniously they folded the mirrors. This is like this, that part like this. And I say this is not deployed, and all thermal shield, everything is folded. And only in orbit it stretched its arms and legs, okay, and became a giant spacecraft. Look at that. James Webb Space Telescope has got 18 mirrors. What are they built from? Beryllium. PUC students, hydrogen, helium, lithium, beryllium. Fourth fourth in terms of atomic number. Second lightest element, okay, beryllium. But beryllium is dangerous. And what it is, of course, high strength, maintains its dimensional stability, okay, and it is strong, but weighs very less, okay. But it doesn't reflect this infrared light effectively. What they did, so they coated a thin layer of gold on each of these 18 mirrors. You may get thrilled. Oh, so much of gold is there in James Webb Space Telescope. You may think, you know how much of gold is there? 48 grams. That's all. Totally, there is a process called vacuum deposition. Through that, they have deposited gold on 18 mirrors, and total weight of gold, which is actually put on the mirrors of James Webb Space Telescope, okay, through vacuum deposition, is only 48 grams, like a golf ball. That's all. Don't think it is glittering with gold, so much of gold. Okay. Now, one thing is about this space telescope mirror. You have to remember, Newton was the first person to build a reflecting telescope. James Webb is also a reflecting telescope. So was the Hubble. Okay, I told you the difficulties. Now, even when you are at Lagrangian point, okay, L2 Lagrangian point, which is say about 1.6 million kilometers from the Earth, away in a direction away from the sun, till the temperature of the sun facing portion of the satellite is about plus 100 degrees centigrade. How are you going to cool? If you don't cool the telescope to minus 230 degrees centigrade, instead of detecting light from infrared light from distant galaxies, the telescope will detect its own light. You don't want the telescope itself to detect itself. So how do you do it? That is why 5 layers of this plastic material coated with aluminum, we call it as mylar. We have also used this in our space program. They were this heat thermal shield was built. It was actually folded, okay. Then everything got opened up. Look at that. Not one layer, 5 layers of that. Each one is as big as a tennis court. How can you build such things technologically? Nothing can go wrong. If something goes wrong, small thing also goes wrong, that mission of James Webb is finished. You can see the tension for scientists who built it and launched it. That is why they were eating their fingernails for breakfast, I said. Okay, on Christmas Day. Look at that. This is the thing. And this is the way. One part is the telescopic mirror. The other part is these 5 layers of heat shield. Here the temperature which is facing the sun is plus 85 or something. On this side it is minus 230 degrees centigrade. That is the way that thermal shield effectively works. And of course, there are 4 instruments in James Webb Space Telescope. One is the camera in the near infrared, that is the one which is adjacent to visible light, red light. Then another is spectroscope in that region. Third one is a middle infrared, still towards the other side. You go middle infrared, okay. That is where it is very, very sensitive and it can study the very first galaxies, okay. This camera, middle infrared instrument, and then you have got a middle infrared telescope, another telescope also. So 4 instruments are there. With the help of these instruments, many things James Webb can do. Let us see what it will do. See, these are the things: middle infrared instrument, fine guidance sensor. You have to focus the James Webb Space Telescope towards a region of the sky. Then look at that space telescope towards a region of the sky. Then look at that. This is a camera, near infrared camera, like that. Cameras are there. They're all on the back side of the mirror. Look at the scientists. They look like scalpel wielding surgeons in an operation theater. And this is the way before launch the James Webb Space Telescope looked. See, on either side of the main mirror, the parts are folded, and this is the thermal shield. This is also folded. Look at that. This is the way, how big it is. You can see this is a model of James Webb Space Telescope. No, the thing is, technologically, it is very, very complex. Today, if there is any problem with James Webb Space Telescope at, let us say, when it is at a distance of 1.6 million kilometers from the Earth, you cannot go there and repair. You repaired Hubble Space Telescope many times and refurbished, and that's why it's working for 30 years. This is supposed to work for 5 years or up to 10 years without servicing. See the complexity there. That is why it's a giant leap technologically also, no doubt about it. And again, I'm showing this is the way James Webb Space Telescope looks. Again and again, I'm showing this. Now, where is James Webb Space Telescope? I told you, there was a French mathematician by name Joseph Louis Lagrange. Okay, he was a French mathematician. He said if there are two large bodies and there is a very small body, then he called it three-body problem. In ordinary, general lectures I would have not have mentioned, but anyway, PU students should know. Joseph Louis Lagrange was a French mathematician in 1770s. He told this, let us say Earth and Sun. In the Earth-Sun system, there are 5 points, stable points. One is this, L2, this is L1, this is L4, L5, and L3. But for James Webb Space Telescope, you have to go away from the Sun. Okay, then you have at least some protection from the Earth. And of course, your thermal shield will be. So L2 Lagrangian point, that is around that point, James Webb Space Telescope is actually stationed, not at L2 Lagrangian point, near that. Actually, they call it as a halo orbit around L2 Lagrangian point. Look at that. This is the thing. Sun, Mercury, the average distance between the Sun and the Earth is 150 million kilometers. But the average distance between the Earth and Hubble Space Telescope is 570 or 600. Moon is nearly 384,000. But L2 Lagrangian point is 1.5 million kilometers. What does the spacecraft do there? It will orbit the Sun at the same rate as the Earth. So you can always see James Webb Space Telescope as at a single point almost. You can direct your antennas towards that. Now in the next 5 minutes, let me tell you, for man is a thinking animal. That is the one which separates him from all other life forms on the surface of the Earth as we know it. Earth is the only abode of life as we know it for sure. For a long time, he has looked at the night sky and wondered, what does it all mean? Why do they move like that? What does it mean? Whatever I see, why it happens like that? Ultimately, where do I fit in this universe? What is my role here? For a long time, man has wondered about it. This is the statue of Pierre Rodin in Paris, okay, thinking man. And he has looked at the night sky for thousands of years using his naked eyes, I told you. His questions are, what are planets? What are stars? What are comets? What is sun? What is moon? Okay? What are stars? What are galaxies? Okay, when did the universe come into picture? What is its present state? How will it end? Are there any life forms in the universe? And what about intelligent life in the universe? These are some of the profound questions that are haunting human beings. Now, see, the Big Bang, which occurred, scientists say, about 13.8 billion years ago, that is the beginning of the universe. And after a few 100 million years, the first galaxies and stars were formed. And that is the time when universe was lit up. Before that, there was only darkness. And once the stars lit up and galaxies were formed, actually, so this was the time when universe was shown in light. How these galaxies were formed. How these baby galaxies coalesced into bigger galaxies like our Milky Way. How did it all happen? How did they evolve into spiral galaxies? These are the things which James Webb Space Telescope can see because it is very sensitive. It can see the beginning of the very first galaxies itself, not ordinary galaxies. Similarly, why infrared rays means there is another thing. In addition to redshifting, see, much of the heavenly bodies in this universe are covered by dust cloud. Visible light cannot penetrate the dust cloud. And so, if you are looking from the Earth, if you are looking at the universe through visible light, you cannot penetrate through those clouds. and see the formation of stars and planets easily. But infrared rays penetrate through dust. That is why, as far as star formation, galaxy formation is concerned, not the very first galaxies, even later galaxies, James Webb Space Telescope can tell us about that. And what about the galaxies? Black holes. Of course, black holes you cannot directly see. You can see a lot of gas and dust, gas spiraling it towards that, and that is the way people say that this is the first picture of a black hole and all. That is not the thing. There is a region which is dark, okay, utterly black, and gases are spiraling towards it, making it a good candidate for black holes. Today I want to tell you one thing. How many planets are there in the solar system? There are 8 planets. That is, we call 8 large bodies in the solar system which are circling the sun as planets. How many planets are there outside the solar system? At least nearly 5,000 of them have been discovered outside the solar system in around other stars. They are known as extrasolar planets or exoplanets. Till now, Hubble Space Telescope and Lyman Spitzer infrared observatory, they had limited capability. They could able to detect indirectly the planets around other stars. But what kind of atmospheres those planets contain, that could not be studied using those telescopes. But now the capability of this James Webb Space Telescope is so overwhelming, it can study the composition of the planets around other stars. Let us imagine there is a planet is formed tomorrow using James Webb Space Telescope, which has got an atmosphere which is similar to Earth in size and density, let us say. And to say it has got an atmosphere with methane, which has got carbon dioxide, which has oxygen, nitrogen. What kind of excitement will be? Our atmosphere is also like that. Chances of finding life in the universe and answering the question, are we alone in the universe? Okay, they become more interesting, and we can tend towards answering those questions, tend towards not answering directly. And of course, as I told you, from Mars onwards, Mars, Jupiter, Saturn, Uranus, Neptune, comets, asteroids, all these things can be actually studied. Okay, especially the Kuiper belt, okay, which is a belt of comets in the outer solar system after the orbit of Neptune. Okay, roughly after the orbit of Neptune. Bodies in that belt, they are so dim, but they emit infrared light. They can be studied using James Webb Space Telescope. So the entire Kuiper belt can be studied. There are so many interesting bodies, okay, which are probably of the size of Pluto also, or maybe bigger than Pluto. Already some of them have been discovered. What do they contain? Those things can be studied to understand their formation, okay. But so whether it is the first light of the universe, that is the formation of first galaxies and stars, okay, or whether the formation of stars and planets around different stars, black holes, and our own backyard, okay, in the solar system. So all these regions, nearby regions as well as faraway regions, can be studied using James Webb Telescope in detail. As you go further and further in terms of distance, you will go back in time also, because light takes 3 lakh kilometers. It has got a definite speed or velocity. So James Webb can do wonders as far as studying the origin and evolution of galaxies and in general the universe itself. Okay, so no doubt either technologically or in terms of its management or in terms of its objectives, it is a giant leap indeed, there is no doubt about it. But I always say there was a great science fiction writer by name H.G. Wells. Many of you may know about him. He wrote a novel called War of the Worlds. He was a very famous one. He said, man may explore the depths of space. Man may solve mysteries of time, but still it will be the end of the beginning and not the beginning of end. It is still whatever we study and understand from the information provided by James Webb Space Telescope, it is the end of the beginning. Still, we are at the beginning of understanding the complexities of this universe. While I say these things, don't forget we have got a good astronomical satellite in orbit around the Earth at 650 kilometers above the surface of the Earth. It has got not one eye, 4 eyes: visible light, ultraviolet light, X-rays, and gamma rays to a certain extent. That's why I remember Sri A.S. Kiran Kumar, who was the former chairman of ISRO, who said, let us not think. Somebody has already discovered so many things. What is there for us? There is something always there for the human beings to discover. Thank you. Thank you very much for your kind patience. I hope I gave you a brief introduction about the capabilities of James Webb Space Telescope. So thank you.
Sir, thank you very much for a very scholarly and informative talk. Bala simple agi, more of pictorial rather than overloaded with words on the
You are
PPT.
muted.
Excellent. ಕೇಳಿಸ್ತಾ ಇಲ್ಲ ಸರ್ ಈಗ?
You are muted.
ಕೇಳಿಸ್ತಾ ಇಲ್ಲ. ಹಲೋ ಹಲೋ
ಕೇಳಿಸ್ತಾ ಇದೆ
ಸರ್, ಕೇಳಿಸ್ತಾ ಇದೆ ಅಂತೆ. ಹಲೋ ಹಲೋ
ಯಾರಿಗೆ ಕೇಳ್ತಾ ಇದೆಯಲ್ಲ? ಎಲ್ಲರಿಗೂ
ಸರ್ ಕೇಳಿಸ್ತಾ ಇದೆ ಅಂತ.
ಎಲ್ಲರಿಗೂ ಕೇಳ್ತಾ ಇದೆ. ನನಗಂತೂ ಎಲ್ಲರದ್ದು ಕೇಳ್ತಾ ಇದೆ.
ವೆರಿ ನೈಸ್ ಸರ್. ನೀವು ಪತ್ರಕರ್ತರಲ್ಲ, ಬೇಗ ಕೇಳಿಸುತ್ತೆ ಸರ್.
ಇನ್ಫ್ರಾರೆಡ್ ವೇವ್ ಲೆಂಗ್ತ್ ಇರಬೇಕು. ಡಾಕ್ಟರ್ ಗುರುಪ್ರಸಾದ್,
ಹೇಳಿ ಸರ್.
ಡಾಕ್ಟರ್ ರಮೇಶ್ had given the clear picture, skills of communication, that you have given us a series of PPTs with no text whatsoever. That's what I like it. Otherwise, most of the, I used to tell him, Papa, don't kill us with your PPTs, with full of text and bullet points, etc., and such a headache to go through it.
Yes.
But this one was one of the rarest ones that I see. Only the pictures. That's how it should be. Communication. What you have in your mind should be expressed, not that what you have written in your notebook. Most of the people read just the notebooks. They project their own notebooks and read it aloud.
Definitely.
But this one is a different one. In fact, I'm really glad that you brought out all the important points related to James Webb Telescope. Particularly, I was more interested whether you will tell about the possibility of explaining the organic materials in the exoplanets using it. This is the only telescope which is capable of recognizing different bondings in carbon bondings. That's a possibility that it might show us whether a planet is alive or not. That you brought forth very conveniently.
Thank you, sir.
ತುಂಬಾ ಚೆನ್ನಾಗಿ ಹೇಳಿದ್ರಿ.
Yes, sir. Thank you, sir. Very kind of you.
This PPT should be shown as an example of proper communication. Most of the science communication that we see is just full of text and text and text and text. I'm so glad.
Thank you, sir. Thank you very much. It comes
from
you means I'm very happy.
Sir, Professor Mulimani sir idare. Sir, Mulimani sir, for your words.
Guruprasad, it was a beautiful talk with beautiful pictures. And you took us all the way to the origin of the universe. I mean, you have created more interest among students about astronomy and astrophysics, which used to be the case earlier. Nowadays, in many universities, somehow they have diluted and taken out those topics. But this is very, very interesting. Just if you can, comment for the benefit of students. This in the region of microwave radiation. That's about origin of the universe.
Correct, sir.
Expanding universe, and
Correct,
that is the proof, isn't it? I mean, whether this telescope will take care of that and trying to explain those things or throwing any more light on this expanding universe.
Sir, actually, at the L2 Lagrangian point only, there is one more satellite called WMAP, Wilkinson Micro Anisotropy Probe, in fact. Okay, that can concentrate towards the microwave region of the electromagnetic spectrum. Okay, actually, this Big Bang, whatever we say, it was contemptuously told by Professor Fred Hoyle.
Yeah.
Okay, that is this called Big Bang in the 1950s, because he's a skeptic along with Professor Narlikar.
Yeah.
Okay, about this Big Bang. Okay, but anyway, that there were Robert Wilson and Sheldon Glasgow, these two people. Okay, the thing is, they found in the state of Maine in the USA that small hiss which was coming at let us say 3 or 4 degrees, 4 degree Kelvin.
Yeah.
4 Kelvin, sorry, degree we should not say, 4 Kelvin.
Yeah.
Actually, that was isotropic almost all over the place. That is why it was a proof of the Big Bang, they said, and they got the Nobel Prize also, in fact.
That Penzias and Wilson, I think.
Yeah, Arno Penzias and Robert Wilson, sorry, not Sheldon Glasgow. Yeah,
so this telescope concentrates on particular areas, particular galaxies, and other things. But if it takes, to the detection of that microwave radiation, it will again give a proof, isn't it?
It will give, but that is not its forte, in the sense it doesn't have the capability. It can look at only infrared, not microwave. Further, different satellites are there.
Okay.
So WMAP is there in the same place, L2 Lagrangian point.
Okay. Thank you, Doctor. Thank you very much.
Pleasure, sir.
Thank you very much, sir. Now we have Dr. Kushal Das, sir, from BLD University, is the director. Sir, over to you for your comments.
Sir, thank you, Dr. Ramesh, and thank you. And I must first give my pranam to my mentor and guru, Professor Dr. B.G. Modimani, sir. He is here. And Dr. Guruprasad, sir, you have given an excellent talk. Unfortunately, I first in few minutes I was out of my laboratory. So, but I joined, and I have no problem, as very clearly mentioned by Professor Hegre sir, that your speech and your talk deliberation was very appropriate for the PUC students to understand what is the space, what is the telescope as such. And I remember when I've seen the photographs and pictures after pictures and all, I was just recollect my memory that when I was in Sapienza University of Rome, Italy, for my fellowship, and that time I had the opportunity to visit the Museo Galileo. So that is in Florence, University of Florence. Third floor, there is the various Galileos, including his thumb finger, ring fingers and all. But I was more curious to see his museum, where his first telescope in the earth, where Galileo has actually made it. And still I remember, I could not take the photograph because it is prohibited there, but I purchased the book on that. So I just remember that how much evolution has been taken place from 16th century to this 21st century to go to this level. So I'm from the medical sciences. So as a faculty of medicine, this is a domain which you have spoken that is always passion to me because it's space. But I am neither expert nor I'm a physicist, and I always feel guilty that I could have been done physics to my subject to understand more in science, which I could not. But definitely such type of lectures for PUC students, enlightened persons like me from the medical faculty, a vast understanding. I'm only curious to know from you, sir, that whether you think that future telescope will be in the moon or in the Mars further for expand further. Do you feel that it should be other planet?
If you have telescopes on the far side of the moon, it is totally free from the radio clutter, which the near side of the moon is affected with.
Right.
So far side of the moon, you will not have the difficulty to stabilize it as you are doing it in the case of James Webb Telescope. You can put it on the surface of the moon itself and you can do observations very well. But reaching the far side of the moon is not very easy. Only China has done till now. Okay? It has reached the far side of the moon. It has landed a rover. Okay? Right. Many people call it as dark side of the moon, which is not correct. It is as lit as the near side. Whenever this is Amavasya here, it is Purnima there. So that
He- he-
is the
he is
way it
very-
is. It is well lit. It is near side and far side, not dark side. So if you place telescopes there, it is very good. But Mars, still Mars telescopes means again you are affected with atmosphere.
Oh,
Of course, atmosphere is very thin, but still it is a hindrance. But unlike our atmosphere, there is no filtering effect as far as Martian atmosphere is concerned, and the surface is baked with all kinds of radiations. So it is very dangerous for us. Maybe
okay.
relatively better in the case of for telescopes. That is. I mean, far side of the moon seems to be a good place. Yes, of course, there are certain difficulties. If we can circumvent them, then it would be a good place.
Thank you, sir. Thank you very much, sir.
Well,
For wonderful explanation. Thank you, sir.
Thank you.
Guruprasad
No
sir,
problem.
there is one question.
Mm.
How far back will James Webb telescope can see?
That is what I said. Say, the Big Bang occurred, scientists say, the cosmologists say that it is about 13.8 billion years back. After a few hundreds of millions of years only, see, the conditions were ripe for the formation of stars and galaxies, maybe a few 100 million years after the formation of the universe through Big Bang. Till that time, James Webb can see things. Let us say roughly around 13 billion light years. Not only it can see, it can show the details.
So, Anthony, are there any other questions?
Dr.
Anthony?
Ramesh, I have a question.
Yeah,
I have a
please, sir,
supplementary.
please.
I have a
Yes, sir.
supplementary
Please, sir,
question.
please, sir.
Tell me,
Please,
sir.
sir.
Dr. Guruprasad, whatever
sir.
has happened to our own Aditya, which is
Sir,
supposed to be there in the L1 point?
yes, sir. But the thing is, since I'm no longer part of ISRO, I too monitor it from outside. But the thing is, it would have been launched earlier itself, because only the instrument which Aditya had in the beginning was a coronagraph. Okay, only corona of the sun to study. But now the Professor Rao said, no, we cannot launch it to low Earth orbit with limited scope and all those things. We will launch it to L1 Lagrangian point, not L2 Lagrangian point. So the thing is about it has got 6 instruments, 6 plus instruments. So that has led to its further evolution, which is complicated, especially if you are launching it to L1 Lagrangian point. The thing is reliability has to be higher. Okay, and stabilization system also has to be more robust. And thanks to Corona and all those things, that's why it has been this one further moved up in the launch manifest. Hopefully this year they may launch it, sir. I feel.
It is sun's corona versus our own corona.
If we can, what can I say, fight this corona, we can launch the satellite and study the sun's corona. As you aptly put it. Thank you, sir.
Thank you.
Sir, one question from a participant, Suprita Nayak. Will the James Webb telescope be serviceable?
For all practical purposes, no. But there are certain reports that certain small, the thing is, nowadays, you need not have human astronauts, human space travelers to go and service it. Actually, in the Earth orbit, the Americans have what is known as RPO operations, that is rendezvous and proximity operations. They have done that in the case of satellites which are circling the Earth at a height of only a few 100 kilometers. But sending something, a robotic a gadget to repair the James Webb telescope, it is quite a formidable thing. And there are reports that certain things are there to grapple it, but NASA has never told anything about it publicly. It said, that is why it has to work at any cost. We call it a single point failure. No single point failure can be there. But wonderfully, it has worked. Now, only thing is the final orbit maneuver they are waiting in the next 3 days. With that, it will be in a halo orbit around L2 Lagrangian point.
ಅಷ್ಟೇ ಅನ್ಸುತ್ತೆ ಸರ್, ಇನ್ಯಾವುದು ಕ್ವೆಶನ್ಸ್ ಇಲ್ಲ.
Good.
We are very thankful to you for a very good, comprehensive and scholarly and informative, insightful talk on James Webb Telescope. I'm sure students would have got very good information from your talk, and some of them will be interested to study astronomy
Yes.
in their future
See, many people ask me,
education.
Many people
sir.
ask me, if we study engineering, can we contribute to astronomy? Yes, you can. People who build scientific instruments, they are engineers, not scientists.
Correct.
Who study the data are scientists. You can still study engineering and contribute. That's what I always say. You need not have to go to astronomy itself, provided if you want to understand the inner workings of the heavenly bodies. That is what is called as astrophysics, physical processes behind the heavenly bodies, working of the heavenly bodies. That is okay. Otherwise, you can do engineering and do things. Anyway, I'm very happy. This was a very august gathering with Professor Moolimani sir and Shri Nagesh Hegde. They were all there. And I'm very happy to be part of this. Thank you. Thank you very much, Dr. Ramesh, for everything.
Thank you very much, sir. I am thankful to our esteemed member of KSTA, Professor Moolimani sir, and Dr. Nagesh Hegde sir, and Dr. Kushal Das sir for joining this webinar. I also thank all the students for joining, and I urge all the students to ask as many questions as possible. When an expert is there, you should ask as many questions as possible. There is no like right or wrong question. You should always ask even a nonsense question, no problem. The expert will always be there to answer your queries. In fact, when I had gone to Canada, there were 25 participants, and all of us had to ask one or two questions in each class. That was mandatory. I think we should make it a mandatory for all the participants to ask questions, whether it is right or wrong. From tomorrow onwards, I urge all the participants to ask questions, as many as possible. Only then you can broaden the horizon of your knowledge. You can understand more. You can expect more from the expert. In the coming days, we'll be organizing one more talk by Guruprasad sir on some other topic. And I, on behalf of KST and all the participants, once again, thank you very much. Thank you, sir.
Thanks to all of you. Bye. Bye.
Thank you.